that it's going to happen. So why don't we go ahead and open up Python 0 workshop. Yeah, so let's talk about Python. What is it? So basically, you have this. So we have two types of users, right? People are probably using Windows and Mac. What I prefer is to run Python in the terminal and in Jupyter notebooks. What you can also do is you can set up a PyCharm environment. So what do they really do? So it's basically you have this interpreter. This thing does the lexing, the parsing, the the interpreting, and you can install this file that's pretty lightweight from the Python official website. And you usually have two versions of it because of the legacy Python. On the Mac, you may have to specify that you want to use Python 3 in contrary to Python 2, and then just some syntax. You can do exit to quit the Python. So there's actually another thing called IPython. It's a little more like better visualized. You can have, it tells you the line numbers, and then you're able to do more, like it gives you a slightly better user interface in comparison to the normal Python. So what Jupyter Notebook does is it basically just calls the IPython interpreter, and so you're able to run Python in that. Some things you can do with Jupyter, but you cannot do with just raw Python is like some 3D visualizers that moves as you drag, for example, some variable values so that the graph moves with your graph. With your measures. So it's basically a calculator, but instead you can do loops, right? So this is like an example of easiest for loop. Sorry. Oops. All right. My bad. Close the bracket. So so you see in the terminal, we cannot really have empty lines in the middle. It only the only way to parse this terminal input is by space. So the program ends when you have an extra empty line at the end, and then that that little piece will be interpreted and executed. But in a Jupyter notebook, it gives you more outputs as you go along. So I guess, does anyone have trouble opening up Jupyter Notebook? We should probably get that started. If you cannot open up Jupyter Notebook, if you're on Windows, open up Python from there, and then you can follow along, but you won't have the script. So okay. How do I see the response? I guess no one has questions. Yeah, just stop me at any time if you need to slow down. So we're going to talk about the basics. So yeah, this is the definition. So basically, in your experiment, you're going to see like a giant Python file. And then the good thing about Python is you can easily read the file without having trouble understanding what each line is doing. In contrast, if you're doing stuff with C++ or like, if you look into the Linux kernel, that each line has like 20 lines of comment because it's really hard to test. So Python is very interpretable. You can see, even though this looks a little bit complicated, but it's really relatively clear. So we're gonna look at how some basic operations are. So you can obviously add numbers. Multiplication needs to be separated with this star, and the exponentiation is you put 2 stars. In contrast, in LaTeX, you would do stuff like this, right? But so this is actually not the exponentiation. It would actually be an XOR operation, right? So what this is doing is in binary you have 1 1 and then what is this 1 1 0. So you do an XOR operation and you get 1 0 1, which is 5, right? Okay, so this is something that may be confusing. So if you're familiar with this, I suggest you to try to do an exercise on this. Like, can you implement a method that finds the solutions to a quadratic equation if you're bored? But so I'm just going to keep going. So one way to check, so let's say in a complicated program, you don't know what this variable is. What can you do? Like, what type is it? Is it a list? Is it a number? Is it a float? Or is it a Boolean? So you can just use this function type. It tells you exactly what type it is, right? So that's helpful. All right, we can run that. Yeah. So you have classes like float, int, string. Python. What other classes are there in Python? You have. Yeah, you will have objects, right? So let's say you have a function, solve quadratic. So something to know is that everything in Python is an object, including integers. This is an integer class object. It inherits from an object class. So so what do you guys think the type of this function would be? We can test that, right? So if, obviously I don't know. We can just run it and see what it is. So yeah, okay, it's a function class. It inherits from the class called like object or something. All right. So we're gonna be dealing with string in Python. So there are a few ways to. So the basic operation of strings is the concatenation, right? We want to stack two strings to display the output. You can use the plus sign, right? So it concatenates that. The complexity of this is not the best. It's actually a big O of the length. So we prefer. I personally recommend you use something called fstring. This is a Python 3 only syntax. And essentially it's more readable. You can have variables in the middle. Only thing you have to do is to wrap around with a curly bracket. And you can, so for example, in this code, what is it doing? This is a tab. So it's like different space on the different machines. It doesn't use the f string. It uses something called format. So format is compatible with Python 2, right? So what is it doing? So in every bracket, it corresponds to the first parameter in the format function, right? You can actually switch orders of that. As you can see, the output of the last two are switched. The problem with this is it's not as readable as the f string, but the complexity is the same. So the question would be, can you convert this into an f string? Like, that's a good exercise to do, right? So we can do that now. So basically, you just replace all the values here with the variable names, right? So this corresponds to that. And then we do the same thing here. Basically, just copy and pasting, a bunch of variables. Let's say it stops here. What's going to happen? You have to find the variables. Okay, so essentially it does that. And then the code will be a lot shorter because you're putting your variable names inside the string. So that's just the preferred way of writing Python 3. So I hope everyone can stick to this convention. This will be helpful, especially Python 2 is, what is it? They're not supporting it after 2020 fall or something. Anyways, okay, so that's string manipulation. Let's look at oh yeah, go ahead. So okay, all right, so let's talk about modules and import. So essentially, the built-in Python is pretty lightweight. It doesn't have a lot of functionalities. For example, you cannot even use square root or like cosine or what example, like Q, like you cannot have the default data structure of a Q. So how would you do that? You need to import from like default libraries. So there are some default libraries. There are some libraries that you need to install. Some default libraries include like math, and then like OS, collections, like a lot more than that. And then you can have, what is it, like JSON if you want to parse a JSON string. So essentially, you have to include that in your code before it imports it. And then to invoke functions inside the library, you need to specify which library is from and then the function. So then it will be able to evaluate your function. Yeah, okay. So on the terminal, what would you do? You would import stuff like math, and then you can do like math square root of 4, right? So this is for the terminal users. Anyways, so if you don't want to do the math.py, this syntax automatically imports all the functions. So then you don't have to specify which library is from. Oh, it just takes the first one that matches anything in there. So in fact, all right, let's just keep it simple. All right, so more about strings. You can index, right? So Python uses, this is the start index. This is the end index plus 1. So in contrast, in C++, right, you don't have this. You have let's say string.substring. The first one is the starting index, and then the second one will be the length, right? So that's a little bit different. I think it makes more sense for like for it to be the end index. So let's say you want to exclude the first character and the last character. You don't really have to count the number of strings, right? You can just use -1, and it would exclude the last character and the first character. So this is a pretty powerful functionality. All right. So if you omit, that means starting from the front, right? All right. And then also if you omit, it means the length of the string. Yeah. Okay. Yeah, you can also count from the back. All right, so this is some string matching. I don't think we need to do this. So what you will probably encounter in your research is you need to parse file names, right? What are file names? If you're dealing with images, your file names will end with .jpg, right? So let's say your file name is ctimage.jpg. In order to get the file name, you will just do, you need to parse or exclude the last 4 characters. So this will do that, right? Okay. So this converts everything to uppercase and lowercase. So if like my advice is, if you have stuff that mixed like camel case doesn't really match your string, you just convert everything to lowercase and do a string comparison. That would be the quickest. So also this is a very good function, like split. By default, you can split by an empty space. So that's what it does by default. But you can also split by other metric, such as dot or like this underscore. So this function is actually a specialty of Python. It doesn't exist in Java and C++. So definitely make use of this as much as possible. All right. Yeah. So yeah. Okay. This is what it's saying. So you can split by a comma, and then after you split, you get a string. So let's talk about the basic types. This Python string is very flexible. It can actually contain different types. Right. So this is by default. This is a default Python string. So what do you guys think the type of this would be? Oh, all right. So this is the default Python list. So for you guys who use like other stuff, you would know that you can convert this list to a NumPy array, and then that type would be a little bit different, right? This will be a different type, like I think is ND array or something. Yeah. Okay. So just make sure you can distinguish between these two, because you cannot do operations on these, right? You cannot add a list to a NumPy list. Make sure you convert it to the same type. Right? This operation wouldn't work. Actually works. Ignore what I said. Anyways, I think if you convert it to like torch tensors, it wouldn't work. But just to be safe, convert it to the same type. Otherwise, the operations, for example, this plus operation may be simple enough, Python deals with it. But let's say you want to do a dot product. I don't know if it works. All right, seems like it still works, but this is not a dot product. It's element-wise multiplication. So if you want to do a dot product, you would do a dot, and then let's see if this works. I think it auto converts it to a NumPy array. So okay, yeah. So a better convention would be you convert it all to a Python to the NumPy array. All right, that was a bit outside of it, but okay. Let's go back to the strings, right? Essentially, you can have a Python list of strings, and then you can concatenate it with this join function. So I guess my exercise for you is going to be like, let's say I love staying at home. Can you invert all the words in this string? Like, how would you use the functions we just talked about, and make it so the result is home at staying love I, right? How would you do that quickly? So the answer is one line. You can think about that. You want to do an exercise. All right. So yeah, okay. So this is more about lists. So the Python list, why is it powerful? It is very fast.
I think I have a question.
Oh, sorry.
No, I'm good. I was just saying that he was right about the tensor. You can't just add them if you're using a tensor NumPy, but there's a wrapper for that too.
Oh, but is it a wrapper?
Like if you do dot NumPy, then it converts it to a NumPy.
Yeah, that's true. You can do dot NumPy as well, but that only works if you're dealing with a tensor, right? Let's say you have a tensor of that. You can. So what's the type of this? Yeah, that's a torch tensor, right? But as Mohammed just said, you can convert it to a NumPy, right? So this is one way to do it. I feel like this way is faster. You should do this. Not the NumPy array. This is for Python list. Okay. All right. So going back to list. When you're dealing with a very large data set, this plus, like if you want to concatenate two very long lists, it's extremely slow to do it in NumPy or PyTorch. So you actually have, so this is for the advanced users, you have a torch concatenate, right? So you can fit two tensors here. Let's make it simple and just do like 5 by 3. So put that in a list. Let's concatenate 5 by 3, but and then 10 by 3, right? So what's the speed of that axis? Let's just do by default. Oh, I'm missing a bracket. Shoot. Concatenate. All right. So what's the syntax for that? Oh, it's cat. Yep. Okay. So essentially, I'm trying to concatenate 5 by 3 and then 10 by 3 on left and right, like dimension 1. That's the problem. So we need to concatenate with the vertical dimension instead of the horizontal dimension, right? So the speed of that is actually very slow. This is big O of n squared. If you're concatenating each row one at a time. So if n being the length of this list that you're trying to concatenate, this list. So if your n increases, and every time it would count everything before it and then add that next one in. So you should avoid using this, but instead you should use it on a Python list. So okay, this is a convoluted way of saying it. Anyways, just try to use Python list as often as possible because the concatenation is big O of 1. So yeah, that goes through that. So you can have different types, and then you can add more with the append function. So inserts 7 after position 6. I mean at index 6. Yeah. You can also remove. I actually didn't know this. I thought you have to do delete. Let's say you delete a third one. Yeah, I always use delete. I never use the remove. Okay, yeah, these two do the same. So you can use delete or remove. Anyways, so the list is pretty flexible data structure. It's an array. It's a stack. It's also well, yeah, it's actually just these two. So if it acts as a stack, you can pop the last element out from it, and then the output of that is the element that's popped. This is different with C++ and Java too, because if you pop, the return of the function is whether the operation is successful. So you would get like nothing here for other languages, but for Python you get what the last element is, which is also pretty helpful. All right. And then this tells you the length. Oh, what does insert do if there's something at the element? Yeah, you can. So yeah, this is a good question. So my answer is, I don't know. You should test it on your machine because there are a lot of details about Python. But good thing is you can just test it instantly, right? For example, we can experiment that. So you literally just open up a terminal and type in like Python and paste it in. And let's see. You insert at position 3. You insert something. So you can test what it is. So it actually inserts at position 3 and everything else is pushed after it. So you're right. Yeah. So yeah, if you don't remember, you can literally just test and then it's pretty fast. So you can sort the list with two functions. You can also do this. Right? So it arranges it by value. All right, reverse, same thing with that. You can use the reversed my list. But after you do that, make sure you assign it, the value. Okay. So yeah, this is actually iterable. So the reverse list is not a list anymore. It's a generator. It's an iterator. So you can convert that to a list by calling the primitive type. What? Oh yeah, because I already did that. Shouldn't be mixing these two. But anyways, let's see. Oh, what? Screwed it up. I need to reinitialize it. Sorry. So strings and that is not comparable. So I don't know where it screwed up. If anyone can point it out, it would be pretty helpful. Yeah, no problem. Okay. Okay, so conditions. Good thing about Python is you don't need the parentheses. The parser takes care of that, but you can add parentheses. The end operation is this. It's not that anymore. So it's just literally the word end. Okay. So this is just syntax. Else if is that, and that's else. And, it'd be good to remember that. All right. So let's talk about loops. So this is Python 3 loops, right? You also have Python 2 loops, stuff like that. I don't know if it works, but let's try that. Yeah, okay. It's not even defined anymore, so you can just forget about that. So essentially, your value. So what is omitting? There are actually three terms here. It goes from 0 to 10 and then increment by 1. So this is what's actually happening. But since Python is simple, it will auto-completes those for you. So let's say you want to go from 0 to 10, but like increment of 2, it would do that too, right? Okay. Oh yeah, okay, it says it here. Oh well. For each. So for each is also pretty flexible. I don't think there's much about that other than I do want to talk about we'll talk about later. Okay, so for functions, you can it needs to be defined before that line you invoke it. So Python goes from line by line, so it wouldn't know what's happening later. Okay, because I defined it earlier. Dang it. Let's say we change the name. Say hi. It wouldn't be defined. All right. So you need to make sure. So what usually people do is to avoid this from happening, you do the main, right? What is it called? I think it was this. I think it was name equals main, right? Stuff like that. And then you execute the main function. So within the main function, you can call that. So what's the order of operation here? It defines these two objects, and then it executes. So then you can call this even if it's behind it, right? Okay, so the main doesn't work on the Jupyter notebook, but it works in the Python file. That's just the definition. All right. Yeah, so how do you convert between numbers and strings. You actually need to convert. Like Python doesn't do that for you automatically, unfortunately. I don't know why. I think it should, but it doesn't. So you need to do that. If you don't do that, it will tell you cannot add a string to a value, right? It says that. Okay. So a little bit about function. What is it called? Function parameters. So function parameters goes in order, but so I want to go a little bit more complicated than that. So this obviously does that. Name becomes KC Hill, and that becomes 0. However, if you have more, I don't know what I'm going to say. Parameters 1. You know, something. If you have more of these, the order no longer holds for that. For example, so once you start to have a default type, the rest needs to be all default types. Maybe you will run into that later, but just know that do this carefully if you want it to have a default values, because it destroys the order. It doesn't preserve order. Okay. Yeah. Fine. I don't know. So this is something pretty simple. So I mean, it overrides it because we are reassigning the parameter. Same for that. Okay. Return is also pretty straightforward. Okay, so since this tutorial is by DSI, they have a pretty good pandas example. So let's go through this line by line. We're importing a library called PD. What pandas do is basically it's a more organized form of a matrix where you can where all the matrix operations are written in C, so it's pretty fast. The only advantage of that is fast, and then it's organized, I guess. So how do we read CSV files? We use their built-in function called read CSV, and then we supply the it could be a local file path. It could be this is actually a URL, right? So it reads whatever is in there into a variable. So this variable now looks like that. It would have, so this is a matrix, right? We actually, each row and each column has its name. Like there's indexing done. There's names for that. So this is where you can start doing, like looking at the data, visualize it, and then see where you can find. There are a lot of things you can do. So imagine you want to look at the, average year of since PhD. So what does this do? It takes out this column, right? And then once you do that, you actually just have a bunch of numbers, and then they're all indexed. We're more interested about the mean, variance, and stuff. So this built-in function does that for you. So for example, if you have NumPy, right? Let's say you have a bunch of numbers. It could be like age or something. So imagine this list is very long. It wouldn't be able to do this, right? It cannot describe the mean because it doesn't have it. We're able to do this because this is not just a list. It's a pandas object, right? So the type of that would be like some pandas core or something that enables C libraries. So then you can do, it's a series. So this enables you to do stuff quickly. Okay. So if you really want to find the means and stuff, you can convert it into a pandas series, but we're not going to do that here. Yeah, this is just more functions of pandas. I don't think you need to do this a lot, but know that you can do that. So when would you need that? Let's say you have labels for your experiments, right? It's also a data frame. I mean, what is a data frame? It's the pandas object that's basically used the most. Let's do an experiment. So I'm going to use a data set that we're working on. I think it was like train or something. Okay, so this is our data set. What is it? It's a bunch of zeros and ones, right? So that's the image name, and then let's make it bigger. Let's look at the head. So well, let's look at more terms. Dang, why are they all zeros? Anyways, so sometimes some of these is one. Let's make it bigger. Okay, yeah, there's one here. So essentially, you have the image name, and then what's the label of that image? So this one is a not epidural. It's that, and then it has one type of that. So let's say what's the length of this whole CSV files? This is way too large, right? For example, I want to count the number of epidurals. How would I do that? So what you can do is you take out the row, right? And then you can just do a sum. So actually, not a lot of these is epidural. So what I mean is, for example, I want to count the number of samples such that it has two classes. How would I do that? Then you need to know some more details about the functionalities of the pandas library. So then you might be interested in knowing more about the details here. But we don't have to go into the details about that. So all right, let's talk about visualizing the data. So I think almost all of the plotting in Python uses Matplotlib. You might see like Seaborn, like Librosa, or like anything else, but essentially their backbone is still Matplotlib. So yeah, like for some of you, it might be helpful to remember some of the commonly used functions in Matplotlib. Right. So what is it doing? This gives the setting of the graphs, because essentially we're going to graph something. That's a function. Yeah, Matplot is kind of, a bit confusing. Because of the axes and stuff, it's less worth learning than the rest of Python. But if you need to make good graphs, you need to remember some details. So yeah, this is literally just calling default functions. We don't do much here. So know that we don't have to use, their data. We can generate data too. Let's say we just generate 100 random numbers, randomly, like normal 0, 1, right? This is not normal 0, 1. This is normal 1, 1. Or is it something else? I don't even know what it is. But yeah, they're all above Oh yeah, this is a uniform 01, I think. Yeah, this is uniform 01. Okay. Okay, so this is the famous data set. I think it's like IROS. Oh no, this is salary data. Never mind. Yeah, you can plot it. Basically, it doesn't say much there. So I think for deep learning research, you might run into visualizations like, you know, TISNI. Like, it's a dimension reducing method to visualize how separated data is. Like, only thing useful is that you can see whether classes are separated when they're reducing down to 2 dimensions. And you're not going to do regression a lot. So this is not that helpful. All right, so let's talk about conda. What is conda? So for those of you confused with like which version of Python you're using, on Windows, I think is where Python, or like which, but like on Mac you do which. It tells you the path where you're invoking the Python interpreter. Yeah, that gives you the version. So this gives you the version, but let's say I have two Python. I have Python 3.6 and 3.7. How would I switch between those? Right? So essentially, you can change the links in your operating systems, but just to be simple, use a conda environment that helps you to do that. On Windows, it's a bit. I actually don't have conda. What the heck? Oh yeah, okay. Okay, Mac is pretty simple. I suggest you use pip, but if you have conda, you can use conda. On Windows, you need to use conda because a lot of things are not supported, unless you do something not as complicated. So there's something called like the environment variables. That's pretty annoying. If you have questions, you can ask me. But on a Mac, if you have conda, this function will help you a lot. It tells you what the list is, but I don't have the example here. It tells you what libraries you already have. Say you have TensorFlow, you have PyTorch, and then it tells you exactly what version it is, and then also where the library is installed from. Such as it might come from the default conda. It might come from the conda forge. There are different library managers that may screw up your things. So make sure that's consistent. Wait. Oh, so if you want to go to a specific version, you do this syntax. Oh yeah, for Mac users, make sure you distinguish between pip and pip3. And if you don't want to use this, I don't even suggest using this. What you should do is you should call the Python interpreter, and then with -m, it will call the corresponding pip. So this is always corresponding to the pip that installs stuff for this Python. So this pip actually invokes like link libraries in your operating systems. So you might screw that up. So if you use that, there's no way of screwing things up, especially on the server. Oh, I need to connect to the VPN. Oops. So on your server, you might already have a conda environment, right? So what? Oh, I mistyped. So you can maintain a bunch of different environments. So let's say you're, by default, you're in the base environment. What does that mean? You have a unique version of Python associated with it. So that's Python 3.7. And then to interchange between environments, you can activate a different environment. And then you will have a different version of Python. I think I should use Muhammad's syntax. So it's like V or something. Okay, it actually tells you a lot more information. Jesus. All right. Well, okay, yeah. Essentially, you saw 3.6 somewhere. Yeah, this is 3.6. All right. Yeah, I suggest you just use this, but whatever. It's not a big deal. What's the other? So each of these environments associate with a set of libraries. For example, you can have one with a newer version of TensorFlow and then the other with an older version, just to make sure you're on the right one to do your task. Okay. Yeah. So Matplot actually goes pretty deep. You can have a lot of like this plotting object is very complex, and if you want to be able to customize how you graph things, you can look at the details and then actually modify some library components so your graph looks nice. Yeah, this is just a Python exercise for you to implement if you're interested, and then that summarizes it. All right, do you guys have any questions, or you're stuck anywhere? We can take a look together. So I hope with this tutorial everyone's able to run Python. Can you share the Jupyter file you went over? Yes. Yeah. So basically, what is Jupyter? It's literally a IPython notebook file, IPYNB. It's kind of large compared to other files. How to find it yesterday? Yeah, it's on the GitHub actually. So if you go to the GitHub, right, drop the link here. You go to the GitHub. You can go through the next few if you think it's helpful, but I think it's too basic for a lot of people. But yeah, this is the instructions IPython file. Tyler made that, but basically you can run this on your machine. So how do you invoke Jupyter? All right, guys, this might be helpful for complete newbies. Like Jupyter can be pretty frustrating if you're not running the correct Python. Do this. So on Windows, you don't have the 3, right? On Mac, you do this, and then you can do Jupyter Notebook. So what this will open a Jupyter Notebook corresponding to this interpreter. So you're not going to have Python 2 on there. Same with Python. It's the same with Windows. But on Windows, you might have to. I think on Windows it would be easier to do. You just like go to the search on the bottom left, and then you can search up Jupyter Notebook. Like from there, you don't have to set up the environment variables. Yeah, I don't know. You might have to see everyone's system. But okay. So okay. So I guess an exercise would be just reading some files that are actually being used, right? Oh, I didn't talk about class today. So the class is basically an object. it's the same as functions, but it's kind of not, but it's really similar. So let's look at that one. Let's look at a class file. Yeah, if you're interested, you can use the IPython, but I don't like IPython. Okay, so let's write a class. What is a class? So you can define a type like dog, or let's be a little more context related. Let's say, so the useful thing would be like a data set, right? What does it represent? We have many files in our systems, right? But we want to organize these files so that when we're training data, we can grab all the files together, right? So let's name it data set. But we want this class to have a lot of wraparound methods, such as, there are a defined set of functions that are useful, such as the length of the data set, the, well, what's in the data set loader? The member functions. So so you'll see why this is useful. So we want to inherit from an object called a data loader. What is a data loader? So this is how PyTorch defines it. So I'm going to go into more about PyTorch now on how to write a data loader. So why do we need this? Why is data loader useful? So we know in machine learning, we're training a set of data. We want it to be robust. So when we take in data, we want it to be random, right? If you're always training on the same set, it's kind of biased, right? It's not fair for the other, or it's not robust. So what does data loader do? It takes all the possible data, like data samples, and then it shuffles it or randomizes it so that your training set is a random sample of your whole data set. So this requires an inheritance, right? So what does inheritance do? It will inherit all the member functions from the parent class. So in this example, our parent class is data set, right? So what is data set? It's a library file in PyTorch, right? You can do torch.util.data. So what functions does it give you? I honestly don't know, but the obvious ones is there is a default get item function that's used, and then there's a default length function that's used. If you want to know more details and then just explore more, you should look at the PyTorch official website. So yeah, the good thing about PyTorch is the documentations are very clear, and there are source code highlighted and then examples that are pretty easy to understand. Where is that? Yeah, there are actually two styles of data sets. I didn't know that, but so for more details, you can check it out. So essentially, it's an iterator. You have many files in this data set, and then get item is actually a random, gives you a random sample from the data set. And then once that order is set, every time you call the same index gives you the same file object. So so what you have to do is you create a class with arbitrary name, and then you inherit from the Torch library. So what does this do? It goes with that. This is where you get all the parent functions. And then these are your member variables. What does that mean? It means every instance of this object has all these member variables. So you are going to override this function from the parent class. Essentially, it takes in a index value and then returns an image based on that, that index. This is where you can customize your stuff. So you point to the directory where you store your images. You store in multiple images. If you store in multiple folders, you can automate some code here. So it's very flexible. You can do anything, but make sure the processing time is slow. Like me and Pena are still working on how to get this faster. So this is not the optimal code, but know that you're basically just inheriting a class and then overriding method. Yeah, so this is the data loader part. Let's look at a training code. So this is one example of a training code. So these are all imports, so it doesn't really matter. We can go back to that. So something we didn't talk about is arguments, right? There's not much to talk about except you can. So there are two types, right? You have the argument with a value that you can attach at the end. You also have an argument that's just on and off. If you call it, it's on. If you don't call it, it's off. And you have to specify the type, obviously. A pitfall for that is they automatically converts types. So let's say your type is Boolean. You notice none of these is Boolean because that's just a bad convention. Like a pitfall is you use a Boolean. Don't use a Boolean because what it's going to do is your input is always a string. So if it's not empty, it's a positive Boolean. If it's empty, it's a negative Boolean. So you literally have to specify an empty string. So that's pretty dumb. So in order to use on and off, don't take in another parameter. Just use action for your if it's present, it's on. If it's true, if it's present, it's true. If it's not, it's false. All right. So you see here we need some string manipulations, right? We want the naming to be correspondent to what experiment we're doing. So this is where your basic skills comes in. Like just basic types can save you debug time. All right, so we'll talk about that later. But okay, let's look at some easy stuff. So let's look at the model. So we all know neural network is a propagation, right? We have the forward and backward propagation. So we're basically evaluating a function. That function has parameters. So the way to do evaluation is, so how do you evaluate a function? You literally just do, function name, parentheses, input, and it gives you the output. Okay. So let's just code that from scratch. So let's say you have a torch, right? We want the simplest model. How can we do that? It's actually in Torch Vision, my bad. So I don't know why, but there are two libraries for PyTorch. Yeah, make sure you don't confuse those two. So this is an example of a model built in the Torch library, right? What is that? It's an architecture. It has a set of parameters, but it acts as a function. So let's make some fake input. So you just randomly generate some inputs. So what does this do? This function randomly generates a torch tensor, right? It's randomly 0, 1, means mean of 0 and then variance 1. It has a dimension of whatever you specify here. So that can be a potential input. So let me show you guys something. Something that will make sense. Matplotlib. This. Okay. So if you randomly generate a vector or a matrix, this is a 30 by 30 matrix, right? You are able to plot that matrix based on the pixel values are between 0 and 1, right? So what is that? That's 0.6, right? That's 0.3, and then the rest. Okay, so basically, this is one way to visualize data. Each point, it's brighter if it's close to 1, and if it's dark, it's closer to 0. Same for the torch tensor, right? Where did we have that torch tensor? So your medical images are just a bunch of numbers in terms of the model. Your input is also a bunch of numbers, pixel values. Oh shoot. Sorry. Yeah. Why is there no interrupt? Okay, so essentially, if that's our input, we can put that input into the model. So we're putting the x into f of x, right? So what's the problem here? The input has to match the model input, right? So this is going to give you an error. The model only takes a specific type of input. It needs to match the dimension that the model accepts. So how do we know what kind of input the model accepts? We need to look at how this model is implemented. So still, this is the same website. And then the docs are pretty complete. Wait. Okay, so this is the ResNet implementation from PyTorch. So as you can see, where I did import torchvision.models.resnet, it's referring to this file. And I actually did ResNet 50 because my experiment is that. So essentially, you are calling an object from here, right? What is this doing? This is a set of parameters from this object. So we can just trace back to what that object is. Let's see where is that? Where is that? Okay, so this is a different object, right? So it takes in those inputs that we just saw, and then it actually wraps around another object. So this is where it gets kind of frustrating because it's like layers and layers and recursively, which is kind of annoying, but it's not bad. You can still find out what it is if you really want to know. So this, it tells you where it is. Okay, yeah. So what is this? Well, what is that? So we have a Python class. This is very flexible. It could be anything, but we name it something. We can also name it something else, but it's inheriting from this model. It's inheriting from this other class. So what is this class? This is a neural network class defined by the PyTorch library. So what does it have? It has default functions called forward. It has default functions called, oh, what? It only has forward? Should have others. Like make layers, it has add modules, and then like a bunch of stuff. But if you want to learn more about what it does, you can also look at the docs for n.module. But the main functionality is forward. So we don't want to go into more details about that. Yeah, this is actually quite complicated. They're wrapping stuff around. So they wrap this around that. And then, okay, so let's go back to this question. I was going off, but we're trying to know what kind of input our model can accept, right? So we need to look at the first layer in the model. How is this model defined? This is the first layer of the model. It's so this is a self object, right? This object belongs to any instance of this class. So what is that? This is, so what is NN? NN is also part of the Torch library. It gives a lot of functions for neural networks. And then you can do NN dot. This is a sort of convolution layers that's used. And it takes a bunch of parameters. So this itself is a neural network, right? So we can treat that as function and do experiments. So if you want to see what this layer does, you can also open up Python and import Torch, and then this gives you the default. So it requires an input channel and an output channel. Let's do 3 to 1. So let's say we're converting a colorful image to a grayscale image. And the kernel size, let's make it the identical. So this is an identical mapping of 3 to 1, right? So if this is a neural network, we should be able to, let's make it simple and clear, layer. All right. So this layer is a neural network. It should be able to act as a function and takes an input. So sorry, I'm gonna do something. So what did I just do there? This is like a convention. So the first one is the number of images. What is a number of images like? It's also the batch size. They're usually equivalent. So for example, you want to do this like in parallel of like 200 images. It's faster on the GPU if you can allocate operations like that. So, you know, that's just the number of images. We can make it 30, but my laptop is not that fast, so I don't want to make it too fast. So the second one is the channel number. You can have 3 channels, you can have 5 channels, you can have 30 channels, but for a colored image, it has 3 channels. And then, you know, for each convolutional layer, it actually expands the channel, right? It gives a lot of possibilities of different channels. So the middle layers, you will have a lot of channels, a lot more than 3. And then these 2 are the pixel dimensions of any image. For example, you can have like more like higher resolution pictures. You can see my stuff is slowing down because of that. Make that smaller. All right. So what's the output? It's converting a 3-channel image to a 1-channel image. So this does the grayscale for that. And it's actually doing convolution. So for more like mathematical intuition, you should look at how convolution works as a mask, it looks like correlations from the beginning of the the beginning of the kernel to the end of the kernel, and then it sees if those values are correlated. This experiment tells you something. If any of your layers don't work or don't work as you expected, you can test it quickly like this, right? Let's say I want to know what is this doing. I don't know what it's doing. What do? You can experiment on your terminal, right? It tells you exactly what it's doing. And if it still doesn't make sense, you can check the docs. You can check it here. Right. So max pool. Right. Oh, I have to do this. Okay. All right. Yeah. So for example, what does the max pool do? It takes in. Yeah, this is actually a lot clearer. So n is the batch size. This is the channel number. This is the height. This is the width. It outputs something similar, right? Kernel size can be precisely defined as that. So your kernel doesn't have to be square, or does it? Well, I'm a bit lost on the math, but you can spend some time and figure that out if it's necessary for your experiment. All right. So go back to our example. Our neural network takes in, where's that experiment? All right. So this is our model, right? This is the ResNet model we have. We can look at the architecture a little bit. So if you just type in model and then evaluate, PyTorch does this, give you the architecture directly. In contrary, in TensorFlow, I don't think it does that. Wait, no, never mind. TensorFlow also does that, but I don't know how. So essentially, for PyTorch, you can look at each layers. They are indexed by tabs. They're indented by tabs. So this will be the first layer, the second. And then this is a layer that's wrapped around with other layers. So at the outside, this whole thing only has 1, 2, 3, 4, 5, 6, 7. It only has 7 layers. But the 5th layer is, it has a lot of layers inside the layer. They're called bottleneck class. It's also a neural network, but something special about ResNet is you can have skip connections between bottlenecks to speed up your convergence. So essentially, let's do one evaluation of an image of size whatever. Okay, so what is this doing? ResNet takes an image and then converts it into a 1000 vector. So this is called like feature extraction, or for your classification task, it acts as a it identifies high level summaries of the image. Okay, so how can you modify your model so that it will do tasks based on your interests? Let's say I want to edit one layer. How would you do that? Right? So I don't want the output to be a 1000 vector. I want it to be 5 vectors because I only have 5 class. I don't have 1000 class. How would you do that? So essentially, this model is made up by a concatenation of a bunch of layers. So you can edit the layer object and then put it back into the neural network. So I think it was just dot. Okay, yeah, it's just dot. So you can assign it with a new value, right? So I don't want to mess it up. So let's do some experiment first. Okay. So this is the linear layer object in PyTorch. So your in feature is 2048, but now I only want the out feature to be a 7 or something. This is just a bias, so you can have you don't have to set it. You know, it gives 1 degree of freedom. So this object is created, but we can assign it to the model, right? So then our model is different now, right? We literally just changed the neural network. And then if you feed any random image into it, and it would only give you a 7 vector, right? So for your task, let's say if this is a classification task, actually I want to do something useful. We all know that the last layer of a neural network can output pseudo probability, right, for classification tasks. So I think I have an example of that. Yeah, I wanted this layer. Actually, I'll just have the whole thing. So what softmax does is, oh crap, this is a variable. So this is when command line is not the best because you cannot have multi-line. Cannot have multi-line instructions. Second. All right, so sequential basically means you don't have to specify the output of this goes to the next layer. It does that automatically for you. But you don't have to make it sequence. You can have many layers, but then for each propagation, you have to specify yourself. So we just want the model fully connected layer to be this. So what is it doing? The output of the average polling layer is 2048, has 2048 channels. So then the linear layer reduces to 7, but then at the end we do a log softmax. So what does the log softmax do? It takes the so this is a ratio on the denominator. In the numerator you have let's just pull out a formula that makes more sense. Nope. Okay, that actually seems like the best one. Oh, come on. Is there a cleaner one? Let's just look at softmax. I'm sure everyone is familiar with softmax, right? So you have 7 elements. You have Z1 all the way to Z7. You take the exponent of it. You exponentiate it, and then you find the ratio of that to the sum of the exponentiated terms. So it's same here, and then at the end you log it. So that's the log softmax. So what's interesting is once you do this, work.rand n. So this is the result vector, right? This is the representations, right? Our representations, what we noticed is we can, is MP here? Okay. I think we might be able to do torch. What? Oh. Okay, so we can do torch that. So the torch of representations should sum up to 1, right? Oh, I hate this. Oh, can't even do that. Muhammad is right. Oh.
You have to wrap it in the no grad first.
Okay, so yeah, the detach is gone, and numpy. Well, I want to flatten it, right? Okay. So basically, it adds up roughly to 1, right? Okay. So in this case, the exponentiated values are acts as a pseudo probability. So what do these values? They have you have a way to interpret these numbers. So let's say you have 7 classes. The probability of being in the first class is 8%, and then the probability of it being in the second class is 17%. So what's your best guess? It's the one with the largest probability, right? So if you have, so how do you find the index of the largest probability? Is there a code that does that? Can someone answer that? This is a pretty tough question. Like, okay, so we want a torch tensor, and then we want the index of the highest number. What's the code for that? So there is a function called argmax that does that, right? So I need to detach and convert it to a numpy array. So at index 4, 0, 1, 2, 3, 4, you have the largest pseudo probability. And then this argmax function works for multiple samples. I don't know if you can do torch argmax. It might work, but I don't know. Okay, it actually works as well. So yeah, basically for classification tasks, me and Charlie here? Okay, Charlie's not here. So basically me and Charlie worked on this, and at the end, if you're doing testing and then you want a multi-class accuracy, you would want to do log softmax in order to get the best accuracy guess. But for a lot of classification tasks, we don't have to do multi-class. We can do a bunch of binary classes and get the mean area under the curve. So that's that tells you how well the model is performing. All right, that's about what I want to talk about for today's. Is there anything you guys want to add? Like, okay. So I guess just more about how we do the training. I want to talk about. Okay, so Mohammed, I guess you also use PyTorch, right?
I mean, sort of.
Okay, like what kind of transformations do you guys use for data processing? Or no, or that's not even done on PyTorch.
I mean, I think the only thing is just normalizing the data from like 0 to 1.
Okay, yeah. I guess, yeah, okay. Let's see. All right, so yeah, go ahead and try the exercise. okay, we can go through this one. Let's go through this exercise. It's pretty fast. So how do we reverse the order of a list? I mean a string. Actually, that's not useful in its own way, but so we're not going to go through that. That doesn't seem useful. What seems useful is, let's say you have, yeah, okay. Let's talk about some language-specific stuff. So there's something called a ternary operator. Basically, it's saying you have a Boolean. If it evaluates to true, the value becomes the first value, and then if it's false, it becomes the second value. In most languages, it becomes, let's say 1 is equal to 2, and then we put a question mark. If that statement is true, we output the first value, and then if it's not true, we output the second value, right? But unfortunately, Python doesn't have that. Python does something more awkward. This is how you write a ternary operator. It's more intuitive. So we output 5 if this statement is true. Otherwise, we output 7. So this is how you write it in Python. So since that Boolean is not true, we output the else. But if it's true, we would output the 5. Another thing I want to talk about is using, just condensing your code into higher quality. For example, you have range, right? This is an object in Python 3 that's helpful for, let's say, anything that involves iteration. So you can actually condense it into that. So what is it doing? It's you're essentially building a for loop, and then for each of the values, you put every one of the values in a Python list, and then at the end, you will get a Python list full of the values that you did operations on. So let's say I want to find all the square values of that. So I would just do that, and then you will get a list of squared values. But I only want the square. Let's say we want a condition on that. If the condition is true, we will include that element in the list. But if that condition is not true, we would exclude it. So this is as far as it goes because you cannot have more for Python, which is not ideal. Anyways, let's do an exercise. So I have 3. I want to name a variable. So let's say I have a variable. I have 2 variables. If they're both true, I want it to be a name. And then if one of it is true, I want each one to have a separate name. How would you do that, in code? So let's say if A, B are both 1, I want to print, print model 1. And then if one of it is, if A is 1, B is 0, I want to print something else. And then if this is the other way around, I want to print something else. So essentially, you can condense your code into one line with the ternary operator. But like a less efficient way to do that would be you just if a bunch of things. If that's 1 and that's 1, we do something, right? Model 1. So our AB is not that. So you can write a function that does that. So print stuff takes in A and B. What? Oh, why is there space? So if A is 1 and B is 1, we print model 1. And, oh. And if A is 1, print something else. So this is a print function. We can start printing stuff out from there. So this is one way to do that, but this is really bad because you have a bunch of if statement and the speed is low and also the code is elongated. How can you condense that into one line with the ternary operator we just mentioned? So essentially you want to do some if else, right? So basically, just to be safe, let's add a parentheses so we don't have any confusions. Oh, my stuff just froze. What? What's happening? Well, so good, a new one. All right. Whoa. All right, forget about that. Okay, so let's try to formulate that. So we have A equals 1 and B equals 1, right? If that's true, we go to this side, right? So it's model 1. However, this is when it's not true, we would have if something else is true, right? Something else is true, it goes here. So it would be model 2. But if that's not true, we would have model 3, right? If B is 1. And at the end, if nothing is true, we have error. But we never define A and B. We gotta define those. Yep. So so this is just one way to efficiently write Python, or if other people write it in this weird way, you can at least know what they're doing without running it. Okay. Yeah, actually, for the concatenation, I think if you input a list, it might not be O and of 2. Let's take a look at that. Yep. Okay. So Mohammed mentioned something important. It was detached, right? I mean, what did he say? He said requires grad, right? So how does let's go to the Torch tutorial. I recommend this. there's no video, sorry. You have to read the text. Right, that. So yeah, we can just start going through that. So all you need to do is import Torch. Make sure if you don't have Torch, you can pip install. Actually, I don't know what that is. I think you need to install both Torch and Torch Vision. So yeah, conda install for Windows users and pip install for Mac users. Yeah, also on the Mac, you're not able to use GPU. Okay. Right. Okay. All right. So what is PyTorch? It's a library for deep learning, mainly because without PyTorch, you cannot efficiently use the GPU for efficient computing. So with NumPy, it's way too slow. You can also build neural networks based on NumPy, but it's really hard to leverage the GPU with NumPy. And raw Python is just impossible. You can't even do matrix multiplication with raw Python. So Torch takes care of that. Is there a C++ PyTorch?
They have wrappers, but I think it's still native.
Oh. Yeah, okay. Anyways, like, okay, for our purposes, let's look at some basic functions. So you can create a Torch tensor. So what is a tensor? It's a bloated word. It's just a matrix. You're creating a ND matrix with the dimensions you specify. So you can print the tensor. So the default tensor does not require a gradient. I should follow along. So there are data types. It's usually a float, but if float is not enough for you, you should use long if you require a lot of precision. Okay. Yeah, you can also have double. I don't know which one's larger, but the default is good enough for me. Yeah, we covered rand, right? Or did we not? Yeah, rand seems like uniform 0, 1. And oh, yeah. So I think you have the identity matrix with the keyword I. That's about it. Oh yeah, rand n means random normal. So it's normal 0, 1. So yeah, NumPy and Torch tensors are about like 1 to 1. Yeah, this is more about the GPU stuff. You can experiment on the server. All right, so the first one is pretty straightforward. So this is where it gets confusing for a lot of people because it requires calculus. But you only have to know that, like for programming sake, you just need to know there's something you can activate. so then it computes gradients. Otherwise, it doesn't. So when you're not computing gradients, it's faster. And then how does it compute gradient is a black box to me. I think their solution is analytical, but for your training, it's very important, because if you're doing this wrong, that you know, you're messing the whole thing up. So I don't know if you want to go to details. So essentially, this will require a little bit derivative, because you know, the gradient is just another word for derivatives, right? Torch, tensor. All right, let's do one example. Let's multiply. Let's do 5 squared, right? So our function is, oh, I forgot to talk about lambda functions. Anyways, let's make it simple. So our function f takes an input, returns x squared, right? Simple. So let's say this is our x. X is 1 by 1 tensor with a value of 5. What's 7, 5, right? So this doesn't accumulate any gradient, because we're not specifying it to compute gradients. The code to activate gradient is this. You set it to true or something. Yeah. Okay. I think there are better ways to do that. It's not good. Well, you can look at it once you have the model. But so in this case, look, before we have x is just a tensor. It doesn't have required grads equals true. After you activate, it becomes that. So and then you can actually check the gradient at x with x dot grad. However, the value is 0. Actually, the value is none. So when you print none, Python doesn't show anything. So it's actually just 0. But notice once you compute the function f of x, this will accumulate some gradient on this result tensor. This result tensor doesn't backpropagate immediately. It stores the gradient in that torch tensor. So it only computes the, so you can check that x gradient still 0, right? But only if you do backward, it would tell everything before, like you contributed this much to my change. So then x will have a gradient. So y is a 10, you know, x squared, derivative is 2x. Evaluate it at x equals 5 is 10, right? So the same happens. So this might be a bit confusing because it's calculus. Essentially, your matrix multiplication is just the sum, is a linear combination of your rows, columns. So it's like what it boils down to, like addition of a bunch of gradients. And the good thing is that you don't have to worry about that. It does that for you. So the confusing part is these gradients from different parameters are independent. This is a good way to explain that. Okay, let's look at a simple example of not using gradient. I think it's pretty straightforward. You can tell it to not compute gradient, so obviously it's not going to compute gradient. So what's the question with our experiment? let's say part of the network requires gradient and part doesn't. How does it affect gradient updates, right? It's too confusing to set it up, but this is something you can think about if it becomes one of your problems. Yeah, all right. So that's about gradients. If you need details, you can refer to this file. And yeah, that's, I think the hardest thing about PyTorch is this, is the gradient. And then neural networks is really just, more layers, but then it's still, the hardest part is still the gradient. So for neural networks, it's just layers takes results from other layers. And then, we iterate through a bunch of these. For example, we have convolutions. This is called a conv1 member variable. And then that's literally just an input to another layer. Okay. So let's read this. I think a good exercise to think about is, let's say first of all, let me copy this class. Oh. I think Penn has a better idea on that number of layers. Okay, let's talk about the general intuition of a neural network. Just some examples. Neural networks are usually like the small ones are like 10 layers, like AlexNet has like 10 or like 14 layers or something. And then you have ResNet, like MobileNet. They're about like 50 to 100 layers, and it can be larger depending on like the task you're doing. But you rarely see networks greater than 200 layers, right? It exists, but like it gets less commonly seen. Why is that? This is because of the gradient diminishing problem. Because so we know our computation has a floating point limit. It doesn't go infinitely accurate. It goes down to like 10 digits, and then it doesn't go any further because we cannot store that. We're doing 64-bit precision, right, for Python. It's not infinitely many precision. So when we're computing gradient and it approaches values like 0 or approaches values that are too large, it becomes inaccurate. And so if we're propagating gradient with way too many layers, these values become like finicky because it's called like there's a term for it. I think it was like machine epsilon or something. So there's this class called numerical analysis that discuss the details of that. It's essentially a neural network is too deep, then your gradients will not be the true values of the gradients. It becomes messed up because you're not accurate. Okay, so designing the number of layers, there's literally just follow what other people is doing. This is like, so their experiment works, and then yours should too, right? So size of layers designing, yeah, this is like a black box to me. I don't know, but for ResNet, they did some experiment. Yeah, there are a lot of effort. So the general pattern is when your neural network is too deep, it becomes sensitive to your hyperparameters, such as the number of neurons in each layer, or the learning rate, the optimization method, and the number of epochs it takes to train the network. So you should take that into account. But usually, if you can get a good set of those parameters, the deeper the network, the more accurate your job is. And then also you're limited with what you have, so you can't really go infinitely deep. Okay. Okay, so still going through this tutorial. I think it's a good time to wrap up.
Any questions from the audience? How's the tutorial pace? Is it too fast or just right or too slow?
I think it was a good pace.
Yes.
Thanks, guys.